This is 3.5, the quadratic formula. In this section, we're going to be talking about a surefire way to solve any quadratic that's in standard form. So standard form is the one where we have ax squared plus bx plus c. So that's this guy right here. Okay? When you have ax squared plus bx plus c equal to 0, you can use this quadratic formula. And what we do is we go through, whoops, I didn't mean to scroll down that far, and we identify the a, b, and c values. So a is the number that's in front of the x squared. And in the formula, it goes there and there. Then we identify the b. B is the number that's in front of the x, including the sign, and that goes there and there. And then c is the number that doesn't have an x attached to it, the constant, c for constant, and that goes right there. Everything else is always in the formula. So the negative sign out front, always in the formula. The plus or minus, always in the formula. The square root, always in the formula. The -4, always in the formula. The 2, always in the formula. So the only things so everything that's yellow stays the same. Everything that is green, blue, or purple changes in the formula. So let's walk through an example or two so that I can show you what this looks like. And rather than write them, I have them typed out ahead of time. So first thing we have to do is identify our A, B, and C. So A we're going to use as blue for this unit or for this section. And then B we're going to use green. And C we're going to use purple. So there's our A, our B, and our C. Now the A appears to be nothing because there's nothing in front of the x squared. But remember, the number that's in front of x squared is 1 when there's nothing written. So we've got 1x squared minus 5x minus 14. So I'm going to go through and I'm going to start plugging in the numbers that we need to plug in. So we're going to plug in -5 for B. So it goes there and there. Then we're going to plug in 1 for A, and we're going to plug in -14 for C. As we solve this, there's definitely an order that we have to use because we have to use order of operations, PEMDAS, as we simplify this down. So if we work from left to right, first thing we see is we see minus -5. So we're going to take minus -5 and turn that into a +5. So that's how this became a +5. Then we've got our plus or minus. We've got an exponent, so we're going to square -5, and that's how we get the 25 that's right here. Then we've got -4 times 1 times -14. So we're going to plug that in a calculator or do it in our heads and get a positive 56. Okay, so we worked through and we did exponent and multiply. Next thing that we're going to do is we're going to work underneath the square root. So we're going to go ahead and do 25 plus 56, which is 81. So working underneath the square root. And then the square root is a perfect square. So we would simplify it normally, but because it's a perfect square, we can take the square root of 81 and we get that 9. Then we do 5 plus 9 and 5 minus 9 using our plus or minus. So remember plus and minus because of the plus or minus that's there. And then 5 plus 9 is 14. 5 minus 9 is -4, and we can do the arithmetic from there. In the next example, we do the same thing. We identify our A as 2, our B as -7, and our C, isn't -13 because this is not equal to 0. So we've got not equal to 0 to start off with. We have to make it equal to 0. So we're going to go ahead and instead of identifying our A, our B, and our C from the original equation, we're going to make this equal to 0. So we're going to add the 10 over to the other side, and instead have our A as 2, our B as -7. Those stayed the same, but our C is -3. And we're going to set up our formula the same way. So A is going to go here and here. B is going to go here and here. And C is going to go right here on the end. Now with this example, when we get down to the square root of 73 is not a perfect square. So we're going to see if we can do a factor tree, which we can't because 73 is prime. And if we can't, then we're just going to write our answer as 7 plus square root of 73 and 7 minus square root of 73, both over 4. So now that we've looked at a couple, let's try a couple by hand. So I'm going to start with number 3 here on the page. And I'm going to identify my A, B, and C. So A is 2. B is also 2. And C is -12. And so into my formula, I'm going to say x equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So that's 2 times 2. And then I'm going to start simplifying. So there's nothing I can do with the -2. That's going to stay put. Plus or minus square root of, let's do some multiplying and some exponents. So I'm going to have a 4, and then 12 times 4 is, let's see, 48, times 2 is 72. So we're going to say plus 72. And if you're not sure, double check. And by all means, double check me. Let's make sure. 4 times 12, no, 4 times 12 is 12, 24, 36, that's 48. I think I said it was 40. Let's try again. 48. And then 48 times 2, 4 and 4 is 8. 96. That's better. Okay. So then I can work under the square root by adding those numbers together. So we'll have -2 plus or minus 100 and divide by 4. 100 is a perfect square, so we can say -2 plus or minus 10 over 4. And that's going to split into 2 options. We can do -2 plus 10 over 4, and we can do -2 minus 10 over 4. -2 plus 10 is 8. 8 over 4 is 2. And then -2 minus 10 is 12. 12 over 4. -12 over 4 is -3. And those are our 2 answers. Okay. And those still, all of these answers still represent the x-intercepts of these graphs. So if we graph this, we would get that as an x-intercept. Let's try the next one. So again, we're going to say A equals 2, B equals -3, C equals -5. So the sign goes with it. Then we'll say x equals, and we'll use our formula, -b, so that's -3, plus or minus square root of -3 squared, put that in parentheses because we want to square the negative, minus 4 times 2 times -5, which is our c value. And all of that's going to be over 2 times our a value, which is 2. So then we start working the arithmetic. Minus a -3 is going to get me a +3. So we're going to have +3 plus or minus square root of -3 squared is 9. Then we're going to have 4 times 2 times 5. Well, 4 times 5 is 20. 20 times 2 is 40. So we're going to have plus 40 all over 2 times 2 is 4. We're going to keep working this. I'm going to work under the square root. So 3 plus or minus square root of 49 over 4. 49 is a perfect square, so I'm going to go ahead and take the square root. So 3 plus or minus 7 over 4. And we can split that into two possible answers. 3 plus 7 over 4 and 3 minus 7 over 4. 3 plus 7 is 10, and 10 over 4 reduces to 5 over 2. And then 3 minus 7 is -4 over 4 is -1. Okay. Let's look at an example. I'm going to skip the next two. Let's look at one of our examples where the answer isn't quite as pretty. Let's do this guy right here. Okay, number 11. So with number 11, first of all, it's not equal to 0. So we've got to make it equal to 0. So we've got to take this x squared that's on the left and move it to the right. So that's going to give us 9x squared plus 4x minus 16 equals 0. Good. So then A is 9, B is 4, and C is -16. So we set up our formula. X equals -b plus or minus the square root of b squared minus 4 times A times C. And that all gets divided by 2 times A. And then we start working the arithmetic. So I've got a -4 plus or minus square root of 4 squared is 16. 4 times 9 times 16. So I'm definitely going to use a little 4 function calculator for this. And I'm going to say 4 times 9 times 16 is 576. And that's going to be a positive 576 because I've got two negatives in that multiplication. And then 2 times 9 is 18. Then inside the parentheses, I'm going to go ahead and do 16 plus 576, which is 592. And I'm going to say -4 plus or minus square root of 592 over 18, which is so pretty looking. And doesn't it all look like the answer that's given to us? But what I can do is I can start taking 592 because I know it's not a perfect square. I can check that real quick. Like I can go ahead and type into my calculator, take the square root of 592, and that definitely doesn't work. But I could try 592 divided by 4, see if I get a perfect square. I do. So 4 is in there. So I could write this. Let's try the next perfect square. So let me do 592 divided by 9. That didn't work. That gave me an ugly decimal. I'll try 592 divided by 16. That gave me 37. So 16 could work. So let's go ahead. So what that's saying is I could make this -4 plus or minus, because there's a 16 in there, I can take out a 4. So 592 divided by 16 was 37. all over 18. Now, if you want to get real fancy, this does simplify a little bit more. It simplifies to the answer that you see up on the screen. The reason that it does is that everything that is not under the square root divides by 2. So because it all divides by 2, I can do -4 divided by 2, and then I could do 4 divided by 2, and I can do 18 divided by 2, but that's not necessary. Okay, that one's a little bit big. So I did that one so that you could see what happens. Let's go back up here and work a few more problems where we have nicer numbers. So for this next one, I'm going to identify my A, which is 1, my B, which is 4, and my C, which is 3. So then I'm going to say x equals -4 plus or minus square root of 4 squared minus 4 times A times C. And that's all going to get divided by 2 times A. And then we start working the arithmetic. So -4 plus or minus square root of 4 squared is 16. 4 times 1 times 3 is 12. And it's going to be minus because there's only one minus sign. And then 2 times 1 is 2. So we've got -4 plus or minus square root of 4, because 16 minus 12 is 4, over 2. 4 is a perfect square, so let's take the square root. So we're going to say -4 plus or minus, and that's going to end up being plus or minus 2 over 2. And we can split into our two answers. We can say -4 plus 2 over 2 and -4 minus 2 over 2. So this is going to end up being -1. And -4 minus 2 is -6, so -6 over 2 is -3. Let's try one more. So the next one that we're going to do is not equal to 0. So notice right away, not equal to 0, we've got to fix that. So we've got to subtract 4 and get 4x squared plus 8x, and then 7 minus 4 is 3, so plus 3, and that equals 0. So our A is 4, the B is 8, the C is 3. Plugging into our formula, we're going to say x equals -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. Then work the arithmetic. So -8 plus or minus, we've got 8 squared is 64. Then we've got 4 times 4 is 16. And 16 times 3, I believe, is 48. It is. So we're going to have -48. And divide by 2 times 4, which is 8. So we've got -8 plus or minus 64 minus 48. Let's double check that one. 64 minus 48 is 16. That was nice of it to be a nice round number. Divided by 8. 16 is a perfect square. So we're going to take the square root and get 4 and divide by 8. And then we can split this up and write our two answers. We can say -8 plus 4 over 8 and -8 minus 4 over 8. -8 plus 4 is -4. -4 over 8 is -1/2. And then -4 minus 8 is -12, and -12 over 8 is gonna reduce, both are divisible by 4, so it's gonna reduce to -3 over 2.